Hi everyone. Today's lesson is drawing and writing electron configuration. We'll talk about the quantum model of the atom and then how we're going to draw and write our electron configurations. This is lesson 2.5. All right. Okay, so where the heck are the electrons in an atom? So that's the big question here. And the answer is that we can never actually really know for sure. We have something called the Heisenberg's uncertainty principle. So what this is a scientist, Heisenberg, and he proposed that we can never know exactly where an electron is in an atom. And that's because as soon as we would shine a light on it to try and find it, we're providing energy to the system, and the electron is going to respond to that and leave its ground state and move to an excited state. So because of that, we never really are ever going to fully know where an electron is. It's impossible for us to figure that out. We can get a good idea, we have a good guess, but we won't know for sure. Now, this is a picture of a character named Heisenberg. So Heisenberg, some of you maybe will have seen this. This is from the TV show Breaking Bad. So Breaking Bad is, of course, this guy was a chemistry teacher and turned drug dealer, and his drug lord name was Heisenberg, and I always thought that was pretty cool because the show never even explained where it came from, so you kind of had to know chemistry to know where he got that name from. So as a criminal, he was saying that you'll never find me, you'll never know who I am. Anyways, a little bit of trivia for you there. Okay, so quantum model of the atom. So we've got the quantum model, and this is going to allow us to make predictions about where electrons are. Now, it's based on two principles. The first is that electrons are particles, and the second are that electrons travel in a wave motion around the nucleus. So we've got our nucleus here, and as you can see here, we have these wave patterns moving around the nucleus, okay? Now, the quantum model predicts the probable locations of the electrons in regions of space around the nucleus that are called orbitals. So we talked about these the other day, and these are S, P, D, and F, and these are described as smoky clouds. So this is a visual of them. So as you can see, they're not solid here. They're very hazy, very smoky, and we know that they're somewhere in there, but we don't fully know where, okay? Now, these orbitals that we talked about are located in sublevels, and those are found in the principal energy levels. So our principal energy levels here, we've got levels 1 to 7, and those correspond to our periodic table, which we'll talk more about later. Now, this was a diagram of the different shapes of the orbitals, and you guys have a diagram of that in your notes here. So we've got S, P, so S is going to be our sphere there, and then P, we've got these sort of lobes here, so they've got lobes going around the nucleus, and then we have our D and our F orbitals, and they start to look pretty weird as we move along here. Now, the question, though, is what sublevels do each of the principal energy levels have? Because they don't have them all. So just as a review here, and this is what we learned the other day, the sublevel S has one orbital. And remember, each orbital can hold 2 electrons. P, sorry, this should be a lowercase p there. P has 3 orbitals, holding up to 6 electrons. D is 5, and F has up to 7 orbitals. Now, this is a diagram here showing as we increase energy, so energy is moving up here in the chart here. These numbers here, 1, 2, 3, those correspond to the principal energy levels. So as you can see here, principal energy level 1 only has an S. Principal energy level 2 is 2S, but then we also have a 2P. 3, now we've got S, P, and D, and so on, okay? And again, I'm giving you a copy of these diagrams so you can see how that works. Now remember, we talked about the amount of orbitals as being related to principal energy level squared, right? So the number of orbitals was equal to the principal energy level squared. So for example, the second principal energy level squared is going to have 4 orbitals, which would be, if we look here, let's highlight, It's those ones and those ones. That's 4 orbitals, right? You can count them there. This will make more sense as we go here, so just be patient here. So the question is, how do they fill? So how do the electrons fill into these orbitals? So if we look back here, the electrons are going to fill according to energy, right? And we know that because of Aufbau's principle, that we're going to go to the lowest energy level first, orbitals, and then we're going to move upwards into higher energy. But the lowest energy orbitals gets filled first. So this is the order of them. So this is the principal energy level. Oops, I'm going to switch back to the pen. Hold on here. There we go. Principal energy levels here. So I've got N1 through 7 here. And this is how you're gonna have to, I would just memorize this chart. You're gonna have to use this chart here because this is the order that they fill. So they're gonna start with 1s, so you're gonna go this way. Then we go to 2s. Then we go 2p, 3s, and then 3p, 4s. So if we're just gonna kind of snake through here, and then like this, and then through there, and we're gonna go all the way through. This seems very convoluted. It'll make more sense as we go here. But these arrows on here, this is, there we go, almost all erased. This is the order that they fill. So basically, this is telling you that, for example, N2 has 2s and 2p. N3, third principal energy level, has 3s, 3p, and 3d. We've got a d sublevel there. The fourth one, we've got 4s, p, d, f, etc., etc. And putting these arrows on the chart like this is a way for you to remember the energy levels, okay? So you're going to need to know that. Okay, we're going to learn this by doing an example, and it will start to make sense as we go here. So the question is to draw and write the electron configuration for an atom of sodium. So we're looking at sodium. So you're going to find it on your periodic table. Your first step is going to be to determine how many electrons there are in that atom. So if we look at the periodic table, this is the atomic number, which is the number of protons, which is also going to be equal to the number of electrons in a neutral atom, right? So I'm going to have 11 electrons that I need to worry about for sodium here. Oops, so sodium has 11 electrons. Now, this is where we are going to determine the sublevels required and draw the boxes to represent them. So I've got my chart here. We're going to look at it. Now I need to get through 11 electrons. Now remember, each one of these orbitals can hold 2. Now in the s's, so I know that I'm going to have to deal with a 1s. So that's going to have 2 electrons in it. And then my next one, so if I follow, I'm going to switch colors here. So I'm going to follow this arrow here. So 1s. Then I'm going to go, now 2s is next. 2s also has 2 electrons. Next, my next one is going to end up being 2p. So 2p orbital, p sublevel has 3 orbitals. So I'm going to draw 3 boxes there, and this is going to be my 2p. Now remember, I only have 11 electrons to place, and each one of these holds 2. So I'm going to be 2, 4, 6, 8, 10, which means I need 1 more, and the next one after that is going to be my 3s. So this will be 3s, which will hold the last one. So these are the sublevels that I'm going to deal with: 1s, 2s, 2p, and 3s. So next step, these are the boxes drawn out here nicely for me. You're going to fill the boxes using arrows to represent the electrons. So remember the 3 rules. So the Aufbau principle we've already talked about. This is the energy levels. So this is where we're going to get our 1. I'm going to switch colors, sorry. This is going to be my 1s, 2s, 2p, and 3s. Those are the sublevels. And now the orbitals within those, remember, they're going to have opposite spins, right? So I'm going to go 1, 2, 3, 4, and then for here, watch, I go 5, 6, 7. So all the spins going in one direction first, and then 8, 9, 10, and then I've got one last one. So I'm going to end up with 3s1 as being my last orbital. So this would be the valence, for example, but we'll talk more about that later. Okay, so, So this would be drawing the electron configuration. So I've now drawn it. The erase function does not work very well. Okay, so 3s here. So this is the drawing, and now I want to write that configuration, okay? So to write it, you're just going to use a superscript to show the number of electrons in each sublevel. So if we look back here, 1s has 2, 2s has 2, 2p has 6, and 3s has 1. So 1s2, 2s2, 2p6, 3s1. This is how you write the electron configuration. I'll just write this over here again. 2s2, 2p6, 3s1. So that would be the written electron configuration. Okay, for sodium. Now, we're going to draw and write the electron configuration now for silicon. So looking at this, silicon has 14 electrons, right? So I'm dealing with 14 electrons. So I'm going to go ahead, I'm going to start, I'm going to use this, this chart here. So I'm going to go 1s, 2s, 2p, 3s, and then from there I'm going to have to go to 3p and then 4s, but I'll come back and do that. Now, okay, so I'm going to go 1s, 2, and then my next one is 2s2. Now, sometimes I actually like to draw my boxes together like this. You can choose how you want to do it. This is 2p6. And I'm at 3s2, so I'm at 2, 4, 6, 8, 10, 12. So I've got 2 electrons more. So let's go back to that chart and find which one we go to next. So 3p is the one we go to next. So this is 3p, but through here, I only have 2 electrons. So let's fill in my boxes here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I go 13, 14. So my valence there is going to be 3p2, right? So the principal energy, 3s2, 3p2 is my valence. So I'm going to end up with those boxes there. So this would be drawing it, and then to write it, you're just going to recopy the bottom parts there. Okay, so that will be the written electron configuration. Okay, next one, we're going to do for nickel. So nickel, we now have 28 electrons to deal with. I'm just going to show you. Yeah, never mind. No, I'm not going to. Sorry. So 28 electrons. So if I look back, I'm going to have to do silicon and then a whole bunch more, right? So I'm just going to do this sort of as quick as I can here. So I've got 1s2, 2s2, 2p6, whoops, 3s2, 3p6, and how am I at right now? So that's going to bring me to what? 2, 4, 6, 8, 10, 12, 14, 16, 18. So I need 10 more. So now I'm going to go back to that chart. I really should have got that picture. Let me just erase here so I can see it a little better. Okay, so I'm at, what am I at? 3p6. So now I'm going to go to 4s2 and then 3d10. So if we look here, I think that might be confusing for some of you. I'm at 1s2, 2s2, 2p6, 3s2, then I did 3p6, then I have to do 4s2, and then 3d10. So let's go back here. So now I'm at 4s2, And then I have 3d10, so I'm going to have to draw 5 orbitals. 1, 2, 3, 4, 5. And this is my, 3d. And then let's figure out how many I need here. So I'm going to fill in, excuse me, I'm going to fill in my electrons. This will look sloppy because of the stylus, but we'll do some examples in class so it's a little clear. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Sorry, that's super sloppy there in the 3D, but we're close, so we need 3D8 there. Okay, and it's got 2 spots there left in that D sublevel. So that would be drawing it, writing it. Again, you're just gonna copy this out. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d8. Okay, so that's how you would do that. Now, I want you to draw and write the electron configuration for the following as your assignment here. So give these a try. We will definitely review this in class, so don't panic if you're having a hard time with this. But I would like you to try these 6 here. So carbon, chlorine, oxygen 2-, potassium positive, and manganese. Now, remember those ones that have the charge, that is going to, the ionic charge there is going to impact what the, how many electrons there are. So make sure you're paying attention to that. Okay, that's it for today.